Hey everyone, so this is our next section in chapter 6. And in this section, we are going to talk about radicals and rational exponents. So we need to remember what this word rational means. Rational numbers, in short, are really just fractions, okay? So we need to remember that so we just kind of don't make it more complicated in our brains, right? These are just exponents that are fractions. And what's cool and why these two things are connected, like radicals and fractions, is because we can change the form from a square root or a radical into a number with a fraction as the exponent. So it says all radical expressions can be expressed using exponents that are fractions. And that's going to help us simplify and evaluate expressions way more easily, okay? So what the rule is that, and here's our example just in terms of letters, so any number can be substituted into these letters, these variables. So it says if we have the index, remember we have the index is that number in the, oh, that's the worst square root. The index is that number right on top of the radical there. And then I've got a number called the radicand, and then I could have an exponent right here. Okay, and so what's important to notice is that the number under the radical stays the same, and the index becomes the denominator, and the exponent becomes the numerator. Okay, so right now it says the nth, if we have the nth root of a, it equals a to the 1 over n. Okay, and so I also want to rewrite that as a to the exponent over index, because that's really helpful too. Okay, so your index becomes the denominator of the fraction in the exponent, and the exponent becomes the numerator. And that's really important to notice. So let's practice. It says 49 to the 1/2. Now, I have no idea what 49 to the 1/2 is, okay? But if I rewrite it as a square root or a radical, then I might be able to evaluate it. So 49 to the 1/2, notice what we have to do. We're going to make a radical. That number stays the same. So now remember what we said. The denominator becomes the index, and the numerator is the exponent, okay? And so now when I look at this, well, this is just the square root of 49. Square root of 49, I know is 7. That's my answer. So 7 equals 49 to the 1/2, which is the same thing as the square root of 49, okay? A little note is anything to the 1/2, that's just the square root. That's what we've been doing all along. So let's check out B, 216 to the 1/3. So again, I have no idea what 216 to the 1/3 is, but let's rewrite that in radical form. So 216 stays the same. The denominator becomes the index. The numerator is the exponent, okay? So I need the cube root of 216. So guys, get out our calculators. We need to use a factor tree. So I'm going to break this down and like this with the factor tree. And I need factors of 216. So I'm just going to do 216, I don't know, divided by 2. Okay, so then I get 2 and 108. So now let's break down 108. I'm going to do 108 divided by, let's do 9. So 108 divided by 9, I'm going to get 9 and 12. And then we're going to break down 9 is 3 and 3. 12 is 3 and 4. 4 is 2 and 2. So see how we break down those numbers until we can't break them down anymore. And what we're looking for is threes. We need triplets of numbers, okay? So let me go ahead and circle some triplets. When we've got triplets, they come outside of our answer, our radical. So I've got triplets right here, right? I've got 3 threes, so I'm going to have 1 3 in my answer. So the triplets become 1. Think about like they come from one mom, okay? That's what goes here. And then I've got triplets of 2s becomes 1. So my answer, the cube root of 216, is 6. So we have to practice those cube roots a little bit more using our factor tree. The biggest thing to remember is the triplets become 1 when we write our answer. Anything that doesn't have a triplet stays under the radical, which maybe we'll see a little bit later on. Okay, let's keep practicing. So problem 2. Now we are going to go the other way around, okay? So the 4th root of 625, I'm going to rewrite that. I keep 625, so now remember our rule. The index is the denominator, the exponent is the numerator. Now remember, if you don't see an exponent, it's 1. So that's the first part of the problem. Rewrite it as a fractional exponent. And now I'm going to evaluate. Now I still don't like to evaluate from the exponent form. I'm going to evaluate from the radical form. So let's break down 625. I'm going to do 25 and 25, and then I do 5, 5, 5, and 5. So now this time I'm not looking for triplets. Last time I looked for triplets because the index was a 3. This time I'm going to look for quadruplets because my index is a 4. So notice I've got 4 5s. That becomes 1, and I've got nothing else, so my final answer is a 5. Okay, let's check out the next one. I've got the 5th root of 32. So let's write this as a exponent, fractional exponent. So remember, the 32 stays the same. The index becomes my denominator. The exponent is my numerator. So that's the first part of the problem. And then we're going to break it down using a factor tree. So 16 and 2 give me 32. Then I'll break down 16 as 4 and 4, 2 and 2, 2 and 2. So I'm not going to look for triplets. I'm not going to look for quadruplets. I'm going to look for quintuplets because the index is a 5. So I'm going to look for numbers that happen 5 times. There are 5 2s. So my answer is 2. Okay, the 5th root of 32 is 2. Let's check out problem 3 here. Evaluate the following expressions. So we can do these a couple different ways. When I see a, the square root of x times the square root of x, we can rewrite that as a fractional exponent. So we know if we don't see a number in the index, it's 2. So really, this is x to the 1/2 times x to the 1/2. And then we can solve this by using our, we know when I multiply variables, the exponents add. So I'm going to do x to the 1/2 plus 1/2 equals x. That goes back to earlier in chapter 6 when we talked about all those exponent properties. Multiply variables, exponents add. Okay, I just needed to see my exponents, right? In this form, we couldn't see my exponents. Let's check out C. I've got the 5th root of x times the square root of x. So I'm going to rewrite this in fractional exponent form. X to the 1/5 times x to the 1/2. And then I'm going to do just like I did before. When I multiply variables, the exponents add. When I add fractions, we know I need a common denominator, so this is going to be 2/10 plus 1/10. And I've got x to the, oh, I'm sorry, this is 5/10 right there. So I've got 2/10 plus 5/10 is 7/10. And so there's my answer. Okay, let's check out B. So what we have to notice in B is 2 things are going on. We've got the cube root of x, y, all raised to the 9th power. So what I would recommend first is distributing that 9th power. So I've got the cube root of x to the 9th, y to the 9th. And then when I bring this to fractional exponent form, I've got the cube root of, oh, I don't have the cube root anymore. I've got x. Remember, the index becomes the denominator. The exponent is the numerator. And then I can simplify, that's 9 divided by 3 is x to the 3rd, y to the 3rd. Okay, same thing, let's check out D. I'm going to distribute that exponent of 2 to everything. So I've got the 4th root of 2 squared, power to a power, remember we multiply. I'm going to do 4th root of 2 squared, that gives me 4, x to the 4th. And then I've got to distribute or rewrite this in exponent fractional form. And so I'll have 4 to the 1/4 x to the 4/4. 4 to the 1/4, this is just x. Okay? And there's our final answer. The rule here is, again, is we take our index, that becomes our numerator, our denominator, and the exponent becomes our numerator. Notice the pattern, remember the pattern, that's what we're going to use. So problem 4, rewrite the radical expression as a fractional exponent, then evaluate. So the square root of 2 to the 4th, we're going to rewrite that. Remember, if I don't see an index, it's a 2. The index becomes the denominator, the exponent is the numerator. So now we just simplify this. 4 divided by 2 is 2. My answer is 4. Right? So here I've got the 4th root of 6 cubed. The index becomes the denominator. The numerator is the exponent. There we go. Okay, we're going to do it again for problem 5. The denominator is the index, and this is what you should be saying in your head when you do these. The numerator is the exponent. And then we've got the denominator is the index, the numerator is the exponent. Just practice rewriting in that form. And so then the last question, the volume of this cube is 216 inches cubed. Find the length of each side. So we know the formula for a volume of a cube is side times side times side. So that's really side cubed. The volume they're telling us is 216 equals side cubed. And how I get this variable by itself is I take the cube root of both sides. And so I need to know the cube root of 216 is just 6. We really won't be doing ones like this a whole bunch, but just so you're familiar, then we could say each side is 6 inches. Okay, great job, guys. This is 6.3. Good job.